If I were to travel back in time and told these people that they will be able to wear the ENIAC computer on their wrist, they would think I'm crazy. Technology has improved in the last 80 years more than it ever has in any span of time. Over the years, we've had a steep growth in processing power, but now we are starting to slow down due to some limitations. One of the factors is heat. The faster the chip goes, the hotter it gets. And we don't have an efficient way of keeping the chip from melting. Another one is leakage. The smaller the processor, the faster it is, but at a certain point, due to quantum physics, we cannot keep track of the electrons. Eventually, processing power will plateau. So where do we go from there? Well, the answer is quantum mechanics and quantum technology and what it has to do with computing. Well, what is quantum mechanics? And how does it differ from regular mechanics? Mechanics is a mathematical description of how objects move through space. Quantum mechanics is how very small particles, such as atoms, move through space. And they move very differently. Particles have some very interesting properties. One of these properties is called entanglement. When two particles interact with each other, they can become entangled. For example, if one particle is spinning clockwise, the other one must be spinning counterclockwise. And this will always be the case. Doesn't matter how far the particles are from each other, they will always be spinning in the opposite direction. Now, what does this mean for computing? In theory, you can send information faster than the speed of light. But this isn't something that we can harness. And I just thought this was interesting. Superposition is the more important property of particles when it comes to computing. Superposition is the ability to represent more than one state at a single moment. Let's take our particle example from the last slide. Right before you take that snapshot, that particle could have been in any other state, rotating left, right, clockwise, up, down, diagonal. Any one of those could have been its position. Traditionally, computers use bits to compute. A bit represents two states, either on or off, 1 or 0. The more bits we have together, the more combinations, aka states, we can have and the more information we can encode for computing. Just imagine if we could have something that can represent multiple states at one time. Well, we do. It's called a qubit or quantum bit. The way you can think about it is a qubit can be 1 and 0 versus a bit which is 1 or 0. A qubit is the quantum mechanical analog of a classical bit. It's a way we harness superposition. Using a qubit to compute is exponentially faster than a bit. Adding just one bit doubles the processing power because you are able to do multiple computations at a time. Here's an analogy. Imagine you are looking for a needle in a haystack, and this would take you a very long time to sift through each twig to find that needle. That's a classical computing, very linear. Now imagine if you had 100 or 1,000 people helping you. Now that process is much faster because you are looking at more twigs at the same time, and that's what a qubit allows you to do. In 2019, Google claimed they had made a quantum computer that made a computation we thought was impossible. It's estimated that this computation would take 10,000 years to compute on the world's fastest supercomputer, and this quantum computer did it in 200 seconds. And in 2020, the Chinese scientists built a computer called Zhihang that is 10 billion times faster than Google's. Now that is really fast. Some final thoughts. I feel like making things more efficient is always a good thing. I can see that there are limitless possibilities with this technology, but do we really need it? What computations are we trying to do that we need that much processing power? What type of materials do we need, and is this cost effective? Does it require more energy to implement? If computers can now compute this fast, what does that say about our security? The 128-bit code for security will have to be increased, and by how much? These are some things that I think about when I think about quantum computers. I am both scared and excited to see what happens in the future.